Welcome, I'm Mike Allinson of ABB, and this is a short tutorial to remind you of the relationship between mass flow and volumetric flow, and how correct selection of the flow variable can lead to significant process optimization and cost effectiveness. In a fluid, whether it's liquid, gas or steam, its density is defined by its mass divided by the volume of the fluid. If you change one of these variables, another will change to balance the equation. To get the best measurement of your process fluid, you must be aware of this relationship. With a dense, stable liquid like water, it's easy to measure it by volume or mass. If you vary the mass by mixing a lower density liquid such as oil, for example, or you have entrained gas bubbles or higher density solids, the overall density will change, and the volume to mass relationship changes. If you allowed liquids with different densities to flow through a volumetric flow meter at the same velocity, you would of course notice no difference in flow rate. If you repeated this through a mass flow meter, there could be a significant change, directly dependent on the difference in densities. Ask yourself, what is your product, process or business based on? Volume or weight measurement? Remember, mass and weight are directly related. If you're buying or selling by volume, you could continue using volumetric flow measurement, of course. But if you are using weight as your final measurement, you need mass flow to make sure that your measurement is as accurate as possible. Take, for example, filling yogurt pots. Yogurt density will vary depending on the amount of fruit in it and the specific recipe of the yogurt. How do you know you're getting the fruit and the recipe you pay for unless you know the mass and hence its weight for a particular volume? Many commodities, including high viscosity liquids, are often priced by weight, not volume. Take another example. If you're buying fuel oil, the weight of the tanker immediately tells you which grade you're getting for your money. The density information from a Coriolis mass meter could warn you if the grade of fuel oil being dispensed is incorrect. In summary, this is what you need to remember about mass meters for various applications. For liquid mass flow measurements, especially where variations in product density are common and the product is priced by weight, Coriolis meters should always be considered. Their high accuracy and repeatability means excellent cost savings, and because product density can be measured, the quality of the product or even its identity can be assessed.